Hello, everyone. Thank you for joining us today. I'm joined here today with Kurt Lee and Heather Schultz, and today we'll be presenting our Tableau story titled Economic Growth and CO2 Emissions. Our team analyzed how economic development relates to carbon dioxide emissions, focusing on two major groups of countries, BRICS and G7. The motivation behind this project is the critical question: can economic growth occur without a corresponding rise in carbon emissions? We know economic growth improves quality of life. It creates jobs, raises income, and lifts living standards. However, growth often comes with a cost. More factories, cars, and energy use, which historically meant more CO2 emissions and a larger carbon footprint. We want to examine if that trade-off is inevitable, or if countries can decouple their economic growth from carbon emissions. To investigate this, we use historical data on GDP, population, and CO2 emissions from Our World in Data repository, a reputable source for global statistics. The data covers many countries over time. We narrowed our focus to the BRICS nations and the G7 economies for comparison. Just to clarify, BRICS refers to a group of large, fast-growing economies, originally Brazil, Russia, India, China, and South Africa, and recently expanded to include others such as Saudi Arabia, the UAE, Indonesia, and more. G7 refers to the group of 7 advanced economies, including the US, Canada, UK, Germany, France, Italy, and Japan. These two groups are key players. Together, they encompass a majority of global GDP and a majority of CO2 emissions. This makes them a great case study for our question about growth versus emissions. On our overview tab, you'll see we have 3 main visuals. CO2 intensity bar chart at the top, a BRICS GDP versus CO2 scatter plot at the bottom left, and a per capita emissions scatter plot at the bottom right. I'll walk us through each of these to set the stage. And just for a little background, we're using 2022 as a quick snapshot. At the top of the overview, we have a bar chart showing the CO2 intensity of each BRICS country in 2022. The most recent data point. The CO2 intensity is defined as the amount of carbon dioxide emitted per unit of economic output. Here it's per $1 million of GDP. This metric tells us how carbon efficient an economy is. A lower bar means a country emits less CO2 for each $1 million of GDP. In other words, it produces an economic value with relatively fewer emissions. A higher bar means more CO2 is emitted per GDP, indicating a more carbon-intensive, less efficient economy. As you can see in this bar chart, there are clear differences among the countries. Some bars are much taller, meaning those economies are burning more carbon for the same GDP output compared to others. For example, countries like South Africa and Russia appear on the high end of CO2 intensity, reflecting heavy reliance on fossil fuels. South Africa's economy, for instance, relies on coal and Russia on oil and gas. In contrast, Brazil's bar is lower, suggesting relatively low carbon intensity, likely due to its use of hydropower and a large service sector. China is somewhere in the middle. It's industrializing rapidly, but also investing in efficiency, so its CO2 per GDP is improving, but still moderate. The key insight here is that 2022, not all growth was equal in carbon efficiency. Some BRICS economies are much more carbon intensive than others. This hints that policy and energy sources, coal versus renewables, for example, make a big difference. If you look at the animation controls, note that the data can be animated over time. We could press play like we did before, see how the intensity has evolved. For now, we're just still going to focus on 2022 for the simplicity of it. Now on the bottom left, we have a scatter plot plotting total GDP on the x-axis against total annual CO2 emissions on the y-axis for the BRICS countries. Each dot represents a country, and the dots are color-coded by country as shown in the legend. We've also sized the dots relative to population to give an extra sense of scale. Large bubble means a larger population. As you can see in the scatter plot, there's a strong positive relationship. Generally, the further to the right, higher GDP, a country is, the higher up, more CO2 it is as well. In other words, higher GDP correlates with higher carbon emissions. This isn't too surprising. Historically, as economies grow, They use more energy and emit more. The most obvious example here is China, the orange bubble on the far right. China is an outlier with by far the largest GDP in the BRICS and also the highest CO2 emissions. Its dot is positioned at the top right, standing out from the rest. India, the red bubble, is also notable. It has a large and growing economy, though not as large as China's, and it's emitting a substantial amount of CO2. India's dot is up and to the right relative to the smaller economies like South Africa and Brazil. We can use Russia and other clustered somewhere in the middle of the pack, higher than smaller economies but below China. The takeaway from the plot is clear. Among BRICS, bigger economies currently mean bigger emitters. China, China's rapid economic rise has come with a steep climb in emissions, and India is following a similar, though still smaller scale path. This sets the stage for why the challenge of decoupling, breaking the link between GDP and CO2, is so important. On the bottom right, we have another scatter plot, but this one adjusts for population by looking at per capita metrics. Here, the x-axis is GDP per capita, average income per person, and the y-axis is CO2 emissions per capita. Again, for the BRICS countries in 2022. This view is important because it tells a different story when we account for population size. Notice how the picture changes on this scatter plot. For example, India now appears on the far lower left of this chart. It has a low GDP per person and also one of the lowest CO2 emissions per person. Despite India's large total emissions and economy in absolute terms, an average Indian citizen's carbon footprint is relatively small. In contrast, look at Russia, Saudi Arabia, and the UAE on this chart. You'll see their positions are much higher up, indicating very high CO2 per person, and relatively far to the right, high GDP per person. Saudi Arabia, for instance, has a high income economy and also one of the highest per capita emission rates among this group due to the oil production and heavy fossil fuel use. Russia and the UAE similarly have a high per person emissions, while China is somewhere in the middle here. China's GDP per capita is about moderate on this set, and its CO2 per capita is also moderate. The key insight from this per capita view is that not all economic growth translates to the same carbon footprint for individuals. Countries like India have achieved growth without high per person emissions so far, whereas others like Russia and Saudi Arabia have emissions per person for their level of prosperity. This highlights differences in energy efficiency, technology, and lifestyle. In short, economic growth's environmental impacts can vary widely. It depends on how energy is produced and consumed and how large the population is. So to summarize this overview, in 2022, the BRICS countries with higher GDP and higher emissions, confirming a strong coupling between economic size and carbon output. However, when adjusting for population and economic efficiency, we see big differences. Some countries are much more carbon efficient, or at least low per person emitters than others. This suggests that it's possible to grow more cleanly, but not everyone is doing it yet. Keep in mind, this is just a one-year snapshot. To really answer our question about growth and emissions, we need to look at trends over time and see if any countries have managed to grow their economies without growing their emissions. Now that we've seen the big picture snapshot, let's explore the dynamics over time for each country. Next, my colleague Kurt will guide us through the interactive Pick a Country tab, where we can dive into historical trends for individual BRICS nations.
Thank you, Scott. Now that we understand the overall landscape, let's take a closer look at each country's story through our interactive dashboard on a Pick the Country tab. On this tab, we have a few interactive elements that allows us to examine historical trends in GDP and CO2 for any one of the BRICS countries. Layout for the interactive tab. On the left side, we have a world map highlighting the BRICS country. Each BRICS nation is colored distinctly, as shown in the legend. We can pick on a country or use the drop-down menu title Choose a BRICS country to select it. We can select a country. The charts on the right will update to show that country's historical data. For our presentation, I'll walk you through a couple of examples. Let's start with China, and then we'll compare it with Saudi Arabia to contrast different patterns. Viewing China. As soon as I choose China, the chart to the right updates to display China's data. On the top right, we have a line chart showing China's CO2 emissions per capita, solid line, and GDP dashed line over time. The x-axis is the timeline years from the 19th century up to 2022. The left y-axis corresponds to CO2 per capita in tons per person, and the right y-axis corresponds to total GDP in inflation-adjusted dollars. The solid line CO2 per capita for China is plotted in one color and the dashed line GDP in another. But since we have only China selected, it's easy to follow both. As you can see, China's GDP, the dashed line, absolutely skyrocketed in the modern era, especially post-2000, reflecting China's massive economic growth. The CO2 per capita solid line also rises alongside it, which makes sense as China industrialized emissions grew. However, pay attention to the relative steepness in recent years. China's GDP line is climbing faster than the CO2 per person line. China's CO2 per capita has climbed to roughly 8 tons per person by 2022, from almost negligible levels decades ago, but its GDP per person increased even more dramatically. This suggests that China has made improvements in carbon efficiency. It's producing a lot more wealth for each unit of carbon now than it did in the past. Another thing to note is that in the last decade or so, China's CO2 per capita line seems to be leveling off slightly, even as GDP keeps rising. This hints that China might be starting to flatten its per person emissions through cleaner energy and efficiency, though it's still rising somewhat. Now look at the bottom chart below the map. This is a timeline of annual growth rates for the selected country. It plots year-over-year GDP growth in percentage and CO2 emissions growth in percentage in the same graph from year to year. For China, you notice two lines in the bottom chart, one for GDP growth and one for CO2 growth. This visualization directly addresses the idea of decoupling. If the GDP growth line stays high while CO2 growth line drops low or negative, that indicates economic growth without equivalent emissions growth. China's growth versus emissions chart is fascinating. It is early high growth years. Both GDP and CO2 were growing very rapidly, double-digit percentages in the 2000s for GDP, and similarly high for CO2. But after around 2010, you can see China's CO2 growth rate line dipping below its GDP growth rate line. For example, in 2012, China's GDP grew about 7.9%, but CO2 emissions grew only around 3%. And by 2014, China's CO2 emissions didn't grow at all. 0% change, even though the economy was still expanding that year. This is visible as a gap on the chart where the GDP growth line is up high, around 7 to 8%, and the CO2 growth line falls to 0. Those years are evidence of partial decoupling. The economy kept growing strongly, but emissions growth slowed dramatically. If you follow the lines further, you will see that from 2012 to 2022, China often had CO2 growth rates lower than GDP growth rates. The trend suggests that China has been working on becoming more carbon efficient, for instance, by developing renewable energy and improving technology. So while the economy kept growing, emissions grew at a slower pace and occasionally even plateaued. China hasn't yet started reducing emission in absolute terms, but is managing to squeeze more GDP out of each ton of CO2, which is an encouraging sign of decoupling in progress. Next, let's compare this with another country, Saudi Arabia, which has a very different story. Viewing Saudi Arabia, on the top right chart now, we see Saudi Arabia's CO2 per capita and GDP over time. Saudi Arabia, being a major oil producer, started with high CO2 per capita relatively early. Lots of oil means lots of emission, even with a smaller population. Its GDP has grown as well, though not at the explosive pace of China's. Visually, Saudi Arabia's CO2 per person line is very high, among the highest in the BRICS group, and has remained high or even risen over time, reflecting heavy fossil fuel use domestically, not to mention that its economy is centered on oil. The GDP line has grown moderately. Saudi Arabia is wealthy, but its growth rate has been more up and down with oil price cycles. Now, look at Saudi Arabia's bottom growth rate chart. The contrast with China is stark. Saudi Arabia's CO2 growth percentage has generally tracked or even exceeded its GDP growth. In many years, the CO2 growth line is right on par with the GDP growth line, and sometimes above it. For example, in 2012, Saudi Arabia's economy grew by about 5.4%, but its CO2 emissions grew by a whopping 12%, more than double the rate of GDP growth. This tells us that economic activities in that year were extremely carbon intensive, perhaps expansion of oil production or power generation leading to outsized emissions growth. Even more recently, in 2021, Saudi's CO2 jumped much faster than its GDP. Our data notes CO2 growth was over 3 times the GDP growth rate. There is a bit of good news in the most recent years. In 2022, Saudi Arabia's CO2 growth dropped to about 4%, while GDP grew around 8.7%. So that year, they actually managed to have GDP growing faster than emission. Still, in general, Saudi Arabia has not yet shown sustained decoupling. Its development has largely been coupled with high emissions growth. The country's heavy dependence on oil and lack of diversification in energy sources like factors here. Using this interactive pick a country view, we could similarly explore other BRICS members, for instance, India might show relatively low per capita emissions growth despite high GDP growth owing to its lower starting baseline and efforts in renewable energy, whereas Russia might look more like Saudi Arabia with closely linked growth and emissions due to its oil and gas-based economy. The interactive map and charts allows us and our audience to pick any country to see these trends instantly, which is a powerful way to understand each nation's trajectory. The big takeaway from this section is that some countries, like China, provide hopeful examples where emissions growth has begun to lag behind economic growth, indicating progress toward decoupling, while others, like Saudi Arabia and to an extent Russia, show that old pattern of grow more equals emit more is still in full force. This interactive exploration underlines that decoupling is possible but not guaranteed. It depends on energy choices, policies, and economic structures in each country. Now that we have examined individual BRICS countries and see how their growth emissions relationships vary, I will hand it over to my colleague for the final part, Heather.
Thank you, Kurt. In this last section of our presentation, we broaden the scope and compare the BRICS versus the G7 directly, and then conclude with our findings and reflections. The BRICS versus G7 tab on our Tableau story provides side-by-side comparisons of these two groups across several key metrics: total CO2 emissions per capita emissions and CO2 per GDP. This will help us see how the patterns for emerging economies differ from the developed world and whether the G7 have managed to decouple growth from emissions better than the BRICS. Looking at the top left chart on this tab, total annual CO2 emissions, G7 versus BRICS, 1850 through 2022. This is a line chart of total CO2 emissions over time with an orange line for the G7 and a blue line for the BRICS. The x-axis is the timeline of years and the y-axis is total CO2 emitted in each year in billions of tons. This chart tells a dramatic story of the shifting balance of global emissions. For most of modern history, the G7 countries, the orange line, were the dominant source of emissions. If you follow the orange line, you can see it rise through the 20th century, reflecting the industrialization and fossil fuel use of the US, Europe, Japan, etc. The G7's emissions reach a peak around the early 2000s. Now note the blue line representing BRICS. For much of the 20th century, BRICS emissions were far below the G7's. Many of these countries were not industrialized yet or had smaller economies. But from around the late 20th century, especially post 1970s and into the 2000s, the blue line surges upward. China, India, and other industrialized rapidly, and by the mid-2010s, the BRICS combined emissions catch up to and then surpass the G7. In fact, in the most recent part of the graph in the 2020s, the BRICS as a group emit slightly more CO2 annually than the G7 do. The crossover point, the blue line crossing above orange, shows how emerging economies have become the leading emitters in aggregate. Meanwhile, the orange G7 line actually starts to bend downwards in recent decades. The G7's total emissions have declined from their peak. Many G7 countries have been reducing emissions through cleaner technology, outsourcing heavy industry, and shifting to service-based economies. For example, the United States, UK, and much of the EU have lower CO2 output now than 15 to 20 years ago, even though their GDPs are higher. This is a clear sign of decoupling at the group level for the G7. They managed to grow their economies slowly, but grow nonetheless while cutting emissions. In contrast, the BRICS have been recoupling, rapidly growing economies with rapidly growing emissions, though as we saw, some of them are attempting to slow emissions growth. So this total emissions comparison highlights a critical point. Historically, the developed nations contributed the bulk of CO2, but the future of global emissions is now largely in the hands of the developing world. Now, on the left bottom chart, we compare CO2 emissions per capita, G7 versus BRICS over time. This chart shows the average annual emissions per person for each group, orange for G7 and blue for BRICS. It gives a sense of individual carbon footprint in rich versus emerging economies. As you can see, there's a big gap. Throughout the 20th century, the average person in a G7 country emitted far more CO2 than the average person in a BRICS country. The orange G7 per capita line starts high and peaks around the 1970s, when industrial activity and car ownership were at their height in the West. After that, G7 per capita emissions gradually decline, thanks to efficiency improvements, shifts to cleaner energy, and also moving heavy manufacturing abroad. By contrast, the blue BRICS per capita line stays very low for much of the early period, reflecting large agrarian populations with minimal emissions, and then rises steadily in the late 20th and early 21st century. It's still lower than the G7 line even today, but the gap has narrowed. For instance, as of recent years, the average BRICS citizen's carbon footprint is still smaller than the average G7 citizens, but it's growing. China and Russia's per capita emissions have approached or even surpassed some European levels, though India's and other are still much lower. So within the BRICS, the variation is huge. What's important here is that the G7's per person emissions are on a downward trend, whereas BRICS per person emissions are on an upward trend. This indicates that lifestyles and energy use in the emerging economies are becoming more like those of developed countries as incomes rise, more cars, more electricity, etc. It also underscores an equity issue. Historically, people in developed nations contributed the most per person to climate change, but going forward, if developing nations adopt the same high emission lifestyles, global carbon output will skyrocket. So far, the data shows G7 citizens still consume more energy and emit more carbon per capita, but BRICS are catching up as developing country continues. Finally, on the right side, we have a chart for CO2 intensity. This is similar to the concept we discussed earlier for individual countries, but now it's aggregated for each group. It's essentially carbon emissions per dollar of GDP for the G7 versus the BRICS over time. This metric directly speaks to efficiency. How cleanly can an economy grow? The trends here are quite telling. The orange G7 intensity line has been declining for decades, especially accelerating after the 1970s. The G7 used to emit a high amount of CO2 for each unit of GDP back in the early industrial era. Think of smoke factories in the 1950s. But that intensity dropped substantially with the advent of better technology, cleaner energy, and economic shifts towards services and high-tech industries. By 2022, the G7's carbon intensity is only a fraction of what it was mid-century. They emit far less CO2 per 1 million of GDP than before. The blue BRICS intensity line, on the other hand, started lower than the G7's in the early years because many BRICS economies were not fully industrialized yet. But it rose during the heavy industrialization phase. For example, when China and India were building lots of coal power plants to fuel growth, their carbon per GDP went up. It peaks and then starts to fall in more recent years as these countries incorporate some efficiencies and cleaner practices. However, the BRICS as a group still have higher carbon intensity than the G7. In 2022, for instance, producing $1 million of GDP in the BRICS group emits on average more CO2 than producing the same output in a G7 country. This makes sense. Many BRICS economies rely on coal and manufacturing, where G7 economies have more services and advanced tech. The good news is the blue line is coming down, indicating the BRICS are becoming more carbon efficient as time goes on, likely through technology transfer, renewable energy investments, and improved regulation. But there's still a gap. The G7 have more resources and earlier start have proven that you can dramatically lower carbon intensity over time. The BRICS are in the process of doing so, but have more to achieve to reach the same level of efficiency. Combining these comparisons, what do we learn? Firstly, decoupling is happening in the G7. They have managed to grow their economies in recent decades without actually reducing total emissions, while actually reducing total emissions. This is an encouraging example that economic prowess doesn't inevitably require ever increasing emissions. Policies like renewable energy adoption, energy efficiency standards, and perhaps shifting heavy industry overseas have all contributed. Secondly, the BRICS are now the driving force of emissions growth globally. Their total emissions have overtaken the G7 and their per capita and intensity metrics are moving upward. Some BRICS members show signs of potential decoupling, but others are still following the old path of growth with emissions. The future of climate change largely hinges on whether countries like China, India, Brazil, and others can continue to develop economically while flattening or reducing their emissions. Essentially, whether they can follow the G7's lead in decoupling, but hopefully at a faster pace and before it's too late. And to conclude, we have a map of the G7 versus BRICS, and you can hover over a country to see the details. So to return to our motivating question, can economic growth occur without a corresponding rise in carbon emissions? Our analysis suggests that it is possible, but challenging. It's not an all or nothing answer. We found that economic growth and CO2 emissions are not entirely inseparable. The G7 experience shows it's feasible to have growth with stable or falling emissions, a result of conscious efforts in technology and policy. And within the BRICS, we saw positive signs. There are periods and cases where GDP has grown while CO2 did not grow as much or at all. True decoupling, where economies grow and emissions actually decline, is starting to happen in pockets. For example, some years in China or overall in the EU and US. However, our data also reminds us that decoupling is not automatic. In many instances, like Saudi Arabia's case, or earlier decades of China and India, we still see the traditional pattern. Growth brings more emissions. The transition to sustainable growth requires deliberate action. Looking ahead, the data gives us a reason to be cautiously optimistic. It shows that with the right investments and policies in renewable energy, energy efficiency, electric vehicles, etc., countries can bend the emissions curve even as they expand economically. The responsibility lies especially with the major economies we discussed. The G7 and the fast-growing BRICS together account for the majority of global CO2 emissions, so their choices affect everyone. If both groups commit to low carbon innovation and cooperation on climate policy, we could see a future where prosperity doesn't equate to pollution. Our analysis indicates that green growth is a realistic possibility. We've seen the first proof of concept, so to speak, in the data. But achieving it broadly will depend on scaling up clean technology and global collaboration. In closing, our Tableau story helped visualize the nuanced relationship between economic growth and carbon emissions. We hope this gave you a clear understanding that economic growth does not have to equal higher emissions forever. The path to decoupling is underway, unevenly, but it's there. It will be up to policymakers, businesses, and all of us as global citizens to ensure that the positive trends continue so that rising living standards around the world need not come at the expense of our planet's health. Thank you for listening, and we'd be happy to take any questions you have about our analysis and findings.